Hi guys, Mr. Starry again. What I want to look at today is, can we graph a line when we're given a slope and an ordered pair? And what we need to understand about this is an ordered pair is a location on a graph. A slope is how we're kind of maneuvering our graph. Remember, the slope is describing the tilt of the line. So we almost need to think of this first point or this first ordered pair as like where we're going to start, and then we're going to use our slope to discover the other point or location that we would need to make our line. What we need to remember is rise over run. Remember, rising up is a positive movement, rising down is a negative movement. Running to the right is a positive movement, running to the left is a negative movement. So let's take a look at our first example here and see what we can do. Notice here's my slope. My slope is 2 over 3. So what this means is my rise is 2. My run is 3. Notice they're both positive. So we should be thinking, okay, I'm going to rise positive, so that's going to be up. I'm going to run positive, so that's going to be to the right. What we do first is we're going to locate this first ordered pair. This is just an ordered pair like we've been plotting for a long time now. To the right one, up one. Remember this location, 1, 1, right here. Now we're going to use this location that I just graphed as like a springboard to our next ordered pair. We're not going to come back to the beginning or the origin again. We're going to start from where I put my ordered pair. So now here's where my slope comes in. I'm going to use my slope movements to discover my second ordered pair. And how I do that is this. Well, I'm going to rise 2. So from my ordered pair, I'm going to rise 1, 2, and that puts me right about there. Now, I don't want to draw a dot there because I'm not done yet. I need to run as well. Okay, so we're right here. Our rise got us to here. Now our run says, okay, we got to run positive 3. Well, positive means I need to run to the right, so I'm going to go 1, 2, 3 units to the right. My location is right here. So I rose 1, 2, I ran 1, 2, 3, and now I have 2 points that I can connect with a line, and I will have drawn this line according to this starting point and this slope. So this is a line that has 2/3 slope, but also contains the ordered pair 1, 1. Let's take a look at our second example. Similar idea happens. Well, we need to have this starting location on our graph. So 2, -4. So that location would be 2 to the right and down 4. So 2 to the right, down 1, 2, 3, 4. And I'd be approximately right here. Now notice my slope is -3/5. And notice that the negative is out in front of the fraction. Now, I want to be able to see rise or run as positive or negative. So I think it's going to be wise of us here to take that negative and assign it somewhere. I think we're probably most comfortable assigning it to the numerator, just because, that's kind of how our brains work, I guess. And from here, it's like, okay, well, same idea as the first one. I have my starting location. Now let's use my slope. I need to rise -3 and run 5. Well, let's rise -3. 1, 2, 3, and then run 1, 2, 3, 4, 5 to the right. This location is off my graph, and that's a problem because now I can't accurately draw my line. So I have to go back to the decision I made at the start of this problem. Maybe instead of putting that negative in the numerator, maybe I can put it in the denominator. What if I put it down here? What if I said 3 over -5? And let's see what that does for us. So let's try this. Let's try rising 3. Well, let's rise 1, 2, 3. Good. I'm still on my graph. And now we're going to run -5. Well, running negative means I need to move to the left. So 1, 2, 3, 4, 5. So notice, just by manipulating where that negative goes in my fraction, I'm able to actually get an ordered pair that's on my graph. Is there an ordered pair down here that would still be a part of this line? Absolutely. It's just for our purposes, I can't really draw it accurately because I don't have the tick marks to show me where it is. If I just kind of move that negative to another location, we can do the same thing, just kind of in a backwards kind of way. Well, I have my ordered pairs. So let's draw my line. Should have done a much better job of hitting that second dot. My apologies for that. But that's kind of the gist of that. Something else to keep in mind is, let's just say, can we do the same thing for positive numbers? Well, of course you can. What if we had positive 3/5? What's another way that we can think about positive 3/5? Well, isn't that equivalent to -3 over -5? Right? So using this kind of idea, we can do the same thing with positive. So instead of rising 3 and running 5, we could rise -3 and run -5. And what you'll notice is all of those ordered pairs or locations on your graph will be in the same location. Again, this doesn't have much to do with this graph here. It's just another idea that kind of comes out of moving negatives and understanding that, hey, we can make both numerator and denominator negative if it helps us with getting our graph on our graph or getting our line on our graph. For our third example, what happens if our slope is a whole number? Well, remember, rise and run, we need to be able to see this fraction in order to determine what our rise and run is. So what we need to do is we kind of need to pull out an old trick of, hey, remember, any whole number or any number for that matter can be written as a fraction over 1. So for example, we could write this as -4 over 1. And what that allows us to do is it allows us to see our rise and run now. So what we can do is we can proceed as normal. My starting point is 0, 0 this time. So I'll put an ordered pair there. Notice my rise is -4. So what I'll do is I will go down -4. Down 1, 2, 3, 4. Again, we're not putting a plot point or anything like that here because we still need to run. Well, what is our run? Our run is 1. It's positive 1, so we need to run to the right 1. Notice I rise and I ran. I'm now ready. I have 2 locations on my graph. I can connect these 2 locations and I now have a line. Just something to check. Notice that after we drew our line, this graph has negative slope to it visually. And just to double check, our slope was negative, so everything should be okay. Our last example here, number 4. We're going to draw a line that has undefined slope. Well, we need to think about what kind of lines have undefined slope. And if you remember from our previous lessons, undefined slope are lines that are up and down. So at the end of this, I should have a vertical line. Well, I want to make sure it goes through this ordered pair, so I need to get this ordered pair on my graph first. So we're going to graph 3, 0. 1, 2, 3. I don't go up and down at all. Right there's my first location. Now, since we're dealing with undefined slope, we know we're going to have a vertical line. So simply all you can do with this one is, hey, I know all lines that are vertical have undefined slope. I can simply just draw a vertical line through that ordered pair, and I'd be done. And just to kind of reiterate, that makes sense, because if you think about it, undefined, we have a 0 in the denominator. And honestly, it doesn't even matter what our numerator is. Let's call it, I don't know, 4. This is an undefined fraction. Any number that's over 0 is going to be undefined. Well, think about what this means in terms of rise and run. I'm going to rise 4 and run 0. So let's just kind of do that. Rise 1, 2, 3, 4, and run 0. That would be right here. Okay, what if I rose 2 and ran 0? Rise 2, run 0. Guess what? That's on my line 2. How about a negative? Let's go -5 over 0. Rise -5, run 0. That's also on my line. So our understanding is when we see undefined slope, that just means a vertical line. And these kind of fractions will do it justice. That's all I have for you today in today's video, guys. We'll talk to you in the next one.